the right option. Okay. So let us first understand how a rumor can spread across the class. So suppose uh, consider a graph of, let's say, only 4 students. For a rumor to spread, we assume that if two people are friends, then the rumor can spread uh, from between these two people. So let's name them 1, 2, 3, 4. Let's say, so if 1 and 2 are friends, then 1 can spread the rumor to 2, or 2 can do the same to 1. If there exists another link, let's say between 2 to 4, then 2 can pass it on to 4 and 4 can pass it on to 2. So this way the rumor can spread. So the presence of an edge determines whether the rumor can spread across the class or not. Now, if now let us analyze these options in the 4 options. So first option, every student must know every other student. So it is so this case, it is possible that the rumor can spread because there exists an edge between any two nodes in the graph. So like if we consider this same graph, so this will be something like this. So everyone knows everyone. So the obvious for obvious reason, the information is easy to spread. But do we require, this is a very strong condition, do we require everyone to be a friend of each other? So this is like it has a it imposes a very strong condition on the network of the class. So we hope this is a sufficient condition but not a necessary condition, so we call this sufficient. Now let us explore the second option. The graph needs to be connected. So what happens if what do we mean by the graph is connected? It means that between any pair of nodes, so let's say pick 1 and 4. So there exists a path between 1 and 4. Between 1 and 4, there is a path. Or in general, let let us call the, if we consider the class, let's say student Si and there is a student Sj, there always exists some, even if they are not directly friends, they student Sj is somehow connected to student Si. So there is a path from Si to Sj, even if Si and Sj are not connected. Even if Si and Sj are not connected. So this ensures that, suppose consider, let's say S1 to be uh, the source of the rumor. Now consider any other student Si. So there exists some path from S1 to Si. So there is a, therefore rumor can pass from S1 to Si. That is meant by connectedness. So therefore this is also a sufficient condition. Okay, now let us hold for a minute. Now consider option
Excuse me, sir. Sir, your voice is not coming.
Uh, Hello, is it better now?
Yes, sir.
Okay, so when did it get muted? Can you just tell? I can then repeat the portion.
Sir, while you are explaining that first question, second bit.
The second option that the graph needs to be connected, right?
Yes, sir. Since that time.
Okay, so I'll just repeat the full question again. So the question is that if there exists a graph where the nodes represent students and edges represents friendship, then for a rumor to be spread across the entire class, you have four options. So every student must know every other student. The graph needs to be connected, or the graph need not be connected, or D, it will spread in any case. So if we consider the first option, if every student knows every other student, so by I took an example of four students in a class, so one, two, three, four. So if everyone knew everyone, then there exists an edge between any two pair of nodes. So the rumors we are assuming spreads by the presence of these edges. So it means that they are friends and they share this rumor among themselves. So if it is fully connected, then of course the rumor can spread because between any two nodes, there always exists a path from any two nodes. So if we consider nodes 1 and 4, there definitely always exists a path. Between 2 and 3, there always exists a path. But this is a sufficient condition, but it is a very strong condition that uh, whether it need not be necessary for every student to be connected with everyone for the information to pass. So that brings us to the second option, the graph needs to be connected. So by definition, it means that if there is student Si and student Sj, so it means if it is a connected network, there is some path from Si to Sj, even if Si and Sj are not connected. So Si and Sj represents the student. So Si and Sj directly may not be friends, but they are related. They have some mutual friends in between them. So that's how the rumor or the information can pass through. So suppose S1 be the source of the rumor. So S1 is some particular student, and we consider Si to be all other students in the class. So for any Si, there exists some path from S1 to Si, and therefore the information can always pass on from S1 to Si. And in this way, the rumor can spread to the entire class. However, if it is not connected, if we consider the this another example of the same network that we take, so here we disconnected three from the all the other students. So there is this the edge between 1 and 2, edge between 2 and 4. It means that 1 and 2 are friends, 2 and 4 are friends, but 3 is somehow excluded. So if 1 is the source of the rumor, it can pass on to 2, 2 can pass on to 4. But there is no way that 1, 2, or 4 will pass it on to 3 because 3 is not a friend of 1, 2, and 4. Therefore, 3 will not know. So one member of the class is excluded. So if the graph is not connected, the rumor cannot spread across the entire class. And option D is will spread in any case. Obviously, this is not true because C is not true. So the right answer for this question is B. The graph needs to be connected because it's a sufficient and necessary condition. The first one is a sufficient condition but not a necessary condition. All right. So if you have any doubt in this part, you can ask me now, or I'll proceed to the next section, next question. Uh, okay. So since no one has a question, I'll take up the next one. So it says that if x equal to random.rand range 5 to 10, which values can x take? So you have four options: 5, 8, 4, and 10. So what this function does, first let me explain. So this function random.rand range, it gives out integers and it considers the first element, but it does not consider the second argument. So it can spit out any integer from 5, 6, 7, 8, 9. For 10, it cannot. So 10 is not included. It is only it can spit out this 5 integers. So what are the correct options here? So it can give out 5, it can give out 8, but it cannot give out 10. So only 4 is not in the list itself. So the right answer is option D. Is it clear? So if you have any questions, you can ask. Uh, all right, so let us take up the next question, which is this very similar to the second question itself, but a slightly different function. So here we have, instead of random.rand range, we have random.randint. So this function also gives out integers. However, it takes in both the two arguments. It considers 3 as well as 6. So you have 3, 4, 5, 6, and all of them are equally likely to be uh, output by this function. So 5 can be a possible output, 3 can be a possible output, and 6 can be a possible output. So the correct option here is option C. 1, 3, and 4, the options 1, 3, and 4 in Roman numerals, they are the valid outputs of this function, and hence option C is the correct answer for this question. Okay, so we'll take up the next question, which is question 4. So what will be the output of the following code snippet? So you have X as 52738. It's an array. And what you do is you first you have a try block and an except block. So in the try block, you try to access element 5 of A. So but in Python, there are only 5 elements in the list. So 52738. The index of this are, however, 0, 1, 2, 3, 4. There is no index 5 in this array or list of numbers. So it will automatically move on to the except block and print that the element does not exist. So option C is the correct answer. Coming to question 5, is there any question from the audience? Uh, okay, so we'll discuss question 5. So what will be the output of the following code snippet again? So first, what you do is you use this input random library, and x is empty. Then for I in range 7, x dot append random dot random 1 to 5. So it's appending into a list, and then you sort it, and then again you append one dictionary. So in the dictionary, this is 1 is to 1 and 2 is to 2, and then you print the length of x. Now what happens before this sort statement is you have a list of 7 elements. So 7 elements in the range of integers from 1 to 5, can be anything. So let's say 5, 4, 1. Okay, so it could be 5, 4, 1, 3, 2, 1, 4. So these are the 7. This is the list that you get till this sort statement is executed, and then you sort it. So on sorting, it will become 1, 1, 2, 3, 4, 4, 5. So so now you have 7 elements in this list, but then you add one dictionary term. So what will happen is it will become 1, 1, 2, 3, 4, 4, 5, and then this dictionary 1 is to 1 and 2 is to 2. So total there are 7 elements from here, and this dictionary is just added as one element in the list. So the length will remain 8, and the dictionary is not added as 2 elements in the list. So it is not 9 but 8. So the option B is the correct answer for this question. Some people are asking me to repeat. So from which portion do you, can you repeat? Okay, so someone is asking how I got the array. So this is a randomly generated array. I picked these numbers randomly by myself just now. So this random.randint will generate some random numbers, random integers considering both 1 and 5. So in between 1 and 5, these are the integers, and I randomly picked them. So that is how I get the array. And then the sort statement sorts this array or a list, and then there are 7 elements in this. And then when this append statement comes, so what this append statement is doing is adding one dictionary to the already existing list of 7 elements. But the dictionary is added as only one element and not as 2 elements. So the length will of the list will remain as 8 and not 9. Uh, Yeah, so the list contains, so someone is asking that it should do from 1 to 3, 4, 5. So uh, it there are 2 1s in the list that I have generated. That's why there are 2 1s in the beginning. Anyone, is this clear? Okay, so let us proceed then with the next question. Okay. So coming to question number 6. So what is the maximum number of edges that can be present in a graph with 10 nodes? So in a graph with 10 nodes, it means that every node is connected to every other node. So let us name this, call the nodes as Vi, any node in the graph. So now Vi has how many total edges does Vi have? There are total
So, sir,
n. Yeah, yeah. Go ahead.
sorry to interrupt, sir, but your screen is not visible. It's blank screen
I,
coming out.
No, it's visible. It's your network issue.
Actually, sir, some of the students are writing in the chat.
how is it? Wait, let me check once.
Yes.
I checked my network. It's the connection seems all right. Can everyone confirm whether it's visible or not? Yeah. So people in the chat are saying it's visible. Uh, I think Balaji, you can check on your side as well if there is a network issue. Okay, so it's visible, I guess. So let us proceed with the question. Uh, okay, so Vi is any node in the graph that I take, and Vi can be connected to uh, at max n minus 1 nodes. So Vi is any node, and Vi in turn can be connected to n minus 1 nodes. So like this, there are n such VIs, n such VIs. So there is total existence of n into n minus 1 nodes can be there. But there is a catch here that if we consider node Vi and Vj, we are considering an edge, then this this n into n minus 1 also considers Vj and Vi. So basically what we'll have to do is total number, we'll have to half this. We don't want to repeat our counting. So total number of edges is equal to n into n minus 1 by 2. So these are the total number of edges. So now if n equal to 10, for n equal to 10, what we'll have is we have 10 into 9 by 2, that is equal to 45. So for a graph with 10 nodes, there can be a maximum of 45 edges that can exist in the graph. If we are not, if you're considering that uh, an undirected graph, so the answer is 45. Is this clear? Okay. Okay, so let us proceed on to the next question, question number 7. So for a complete graph with 5 nodes, if A equal to Z dot order by Z dot size, what will be the value of A? So A is a complete graph, means fully connected graph. So Z dot order gives total number of nodes, and Z dot size gives total number of edges. Now if n equal to 5, Z dot order is going to give 5, and Z dot size is going to give, since Z is a complete graph, so complete means fully connected, it is going to give n into uh, uh, it's going to n into n minus 1 by 2, so that is equal to 5 into 4 by 2, that is equal to 10. So the ratio A is basically 5 over 10, that is half. So the right answer for this question is option C. Uh, okay. Is there any doubt regarding this question?
Sir,
Yeah, go ahead. Hello. Is there a question? Uh, if you have a question, you can type it in the chat box as well. Okay, so I'll proceed with question 8. If you have a doubt, then wait, someone has said it. Okay, so if there are any doubt, you can ask me at the end of the session as well. Okay, so coming to question number 8. So what will NX dot Dijkstra path GUV return? So G is the graph, G is the graph, U and V are nodes in the graph. So what this Dijkstra does, it return. So this name Dijkstra comes from this famous computer scientist who's who gave this shortest path algorithm. So gave the shortest path algorithm. So it basically is to find the shortest path between any two nodes in the graph. So that is the answer, straightforward answer. That is option A. It returns the shortest path from U to V in a weighted graph. Weighted graph, by weighted graph means that two edges can have different width. Consider a road network. So this algorithm was initially given for such an network. So distance between uh, any two cities, let's say city 1 and city 2. So distance between city, it is the weight of that edge. So it returns. Okay, I changed it. So can someone tell where I lost? Where did I get muted? I can start again.
Two cities, sir.
Can you repeat again?
Two cities.
Okay, I'll repeat the full question again. So, what will nx.dijkstra path GUV return? So, this G is the graph, any given graph. U and V are the nodes in the graph. So, what is this Dijkstra function does is Dijkstra, it's named after this computer scientist Dijkstra who gave the shortest path algorithm between two nodes. So it is like he gave this algorithm to find the shortest distance between, let's say, two cities. So what is the distance, shortest distance to go from city C1 to city C2? If and by a weighted graph, I mean the distance between two adjacent cities. So if C1 and C2 are adjacent cities, what is the distance between them? The weight is D. So in such a graph, it is called a weighted graph. In such a graph, the this function, this Dijkstra underscore path, it returns the shortest path from U to V. And the second option is return the shortest path length. It does not return the shortest path length. Path length would be the number of edges or the hops to reach from one node to another, but it actually returns the distance between u and v and not the number of hops. So returns all possible paths from u to v. No, it doesn't do that, and returns number of possible paths from u to v. Also, it doesn't do that. So the right option is A. Um, is that clear? Okay, then I'll proceed to the ninth question, which is what will nx.gnp random graph 20 0.5 return? So what this function does is basically graph 20 0.5. So what it does, it generates a graph with number of nodes equal to 20, and then it assigns edges based on this probability. So this 0.5 is a probability. So there are in total n into n minus 1 by 2 edges. So that is 20 into 19 by 2, that is 190 edges. Now it goes through all the 190 edges and selects and considers whether it should include that edge with probability 0.5. So it's like basically flipping a coin to make a decision whether to include the edge or not. So this function does that. So it returns a graph with 20 nodes with each edge to be put with a probability of 0.5. So the option B is the right answer for this question. Uh, is this clear? Okay, all right then. So let us move on to the final question for our discussion today. This is the question 10. So, what is the maximum number of graphs possible from 50 nodes? So you have a graph of 15, you have 50 nodes. So how many graphs can you create? So let us consider, first of all, before solving, let us consider what this problem is trying to say. So by considering a simple case of, let's say, 4 edges, 1, 2, 3, 4. So you can have, this is, this can be one possible graph. Second, you can have again 1, 2, 3, 4. You can have, this is one graph. This, let us call it G1. This is G2. And again, we can have another graph like this, where they are connected like this. So this is, let's say, G3. So the question is asking us how many such graphs can be there. So how many G1, G2 to Gn, there can be such Gn. So what is n? So how, if we are given the number of nodes, we know the number of nodes, in this case 4. So we, how many variety of graphs can we get from the combination of this 4 nodes? So in our problem, instead of 4, there are 50 nodes. So how will we solve this problem? So what is the, so first let us consider how many total number of edges can be there in a graph of 50 nodes. In a graph of let us write in a graph of 50 nodes, total number of edges equal to 50C2, or written like this. So it's basically n into n minus 1 by 2. So you pick any two vertices, any two nodes, and you draw an edge between them. So the total number of ways you can pick two nodes is given, is the total number of edges, which is 50C2. So this is the total number of edges. So let us call this number as Let's say capital N. So capital N is the total number of edges, and small n, let us denote this as small n, is the total number of nodes, 50, and n, capital N, is the total number of edges that. Now what we do is we select. Okay, so what we do is we select the edges like this. So we consider edge 1, edge 2, edge 3, and edge n. So this is basically 50C2. N is equal to 50C2. Now we can consider that 0 means is the edge is considered in the graph, and 1 is 0 means it's not considered, and 1 means it is considered. Similarly for edge 2, it can be either considered or not considered. And the same goes for all the edges in the among the capital N number of edges. So you have two choices. So the total permutations that you can obtain is basically 2 to the power capital N. So this is the answer for the number of graphs. So 2 to the power capital N variety of graphs you can get from if you are given small n number of nodes. So for our problem, capital N is 50C2. So the right answer for this question is option B. So that is the answer. So if uh, that brings us to the last question of our discussion. So if you guys have any questions, so any of these 10 questions that we have discussed so far, or any other doubt, so you can ask, you can type in the chat box or just unmute yourself and speak up. Yeah, it's 2 to the power 50C2. It's so it's a very big number, so I don't know how to calculate and write it over here. Oh, all right then. So if no one has a question, okay. So someone has a question. Let's see. Okay, can you please say how to do question one? So uh, just 1 minute. So first, I'll go back to question one. Okay, so the question one is asking that if there exists a graph where nodes represent students and edges represent friendship, then for a rumor to spread across the class, you have four options. So whether every student must know every student, the graph needs to be connected, the graph need not be connected, and D will spread in any case. So what assumption we are making is that the rumor will spread across the edge. So we considered a simple example of four graphs, four nodes. So there is a class of four students. So here, an edge represents there's a friendship between the two, and by friend, I mean they can share the rumor among themselves. So if it is fully connected, obviously the rumor can pass because between any two friends there is always a path. So even if they are, and if every student know every other student means they are friends with everyone. So the source, the person who is the source of the rumor can directly tell to any other student. So option A is correct in a way, but it is a sufficient condition. If we consider option B, the graph needs to be connected where every student need not be friend with everyone. So SI and SJ, let's say be students SI and student SJ. So there is a path from Si to Sg even if they are not directly connected. So they might have mutual friends. In that case also the rumor can pass, because if let's say S1 is the source of the rumor and Si be any other student from the class, there always exists a path from S1 to Si. So the rumor can pass from S1 to Si. So the option B is the sufficient and necessary condition. So if the graph is not connected, I have shown it in this figure over here. So if let's say 3 is not connected to 1, 2, and 4. So in this case, 3 is completely isolated. So it will not, if let's say 1 is the source of the rumor, it can pass on to 2, 2 can pass on to 4, but no one passes it on to 3. So 3 will be left out. So therefore, uh, uh, it is necessary for the graph to be connected. So option C is not correct and option D is not correct because C is false. So it will not spread in any case. It has to be connected. Okay. So this is question 1. Okay. 10th question someone is asking to repeat. I'll do that. So okay. So it is asking us to find the maximum number of graphs possible from 50 nodes. So let us first, before solving for 50 nodes, let us solve a simpler problem. So let us say we have 4 nodes, 1, 2, let's say 1, 2, 3, 4. So this first one is G1. This can be one variety of node where there exists only an edge between 1 and 4. G2 can be another variety where the edge exists between 2 between 2 and 4 and 2 and 3. So this is another variety. G3 can be another variety of node. So what the question is asking is how many such varieties of nodes can be there. So let's say, wait. So it is basically asking this. So let's say G1 to Gn, there are total variety of nodes. So this is all possible variety of graphs. So what we want is what is n. So we want how many variety can exist. So let us solve this problem for 50 nodes now. So for 50 nodes, what it's asking is, if we have 50 nodes, the total possible number of edges will be 50 C2. Why? Because for any, how is total number of edges decided? So you pick any 2 nodes, so and you draw an edge between them. So that gives you all possible variety of edges, which is discussed as n into n minus 1 by 2, which is also as the combination of picking 2 nodes from a pool of 50 nodes. So it's 50 C2, and let us denote it by this letter capital N. So now consider all the capital N number of edges. So E1, E2, E3, En. So these are the edges. So let me write. So E1, E2 till E capital N. So these are the edges. Now we can have the edges selected. Don't select. So either you select that. Sorry. Uh, it should be the reverse. Either you don't or you select it. So 0 represent you don't select that edge, or 1 represents that you select that edge. So it can be 0, 1, 0, 1, 0. So for every node you have 2 options. So 2 into 2 into 2 into 2 to the power n. So total number of options will give you the total variety of graph, that is 2 to the power n. And for this question, that n is 50 C2, so it is represented like this in this braces 50 by 2. So this is option B is the correct answer for this question. Uh, all right. So I discussed question 10. Someone had a doubt. So if anyone else has any further questions, you can ask. Write it in the chat box. Uh, all right, then I think people do not have any further questions regarding this assignment. So we'll again meet next week and I'll discuss week two's question answers. So someone had asked that what is the exam pattern? So uh, I I am not actually responsible for setting the exam pattern. I am only allocated the duty of solving this assignment. So someone uh, else is actually deciding the exam pattern. You can write directly to the NPTEL uh, team who is responsible for the organization of this course. They will know better. So I really don't know what the exam pattern is going to be. Yeah, so whether the exam is easy, that is a very personal question that will depend from student to student. But mostly, I believe the instructor is teaching very well. And if you do this, if you attend these tutorials and solve the assignments on your own, I think you will do very well in this course. Uh, any other question from anyone? All right then. So I think we can close the session for today. I'll meet you again next week at the same time and we'll discuss week two's assignments. All right then. Thank you everyone for taking the time to joining in for this tutorial session. I appreciate your efforts and all the best for the course.